Let us start our weekly classes today. I hope the students will others will join very soon. Now, yesterday, in the last class we have discussed water tube boilers. What was this? What is the essential difference, and what are the different type of boilers we have discussed so far? One is fire tube boilers, and another is water tube boilers. Fire tube boilers are having the hotted flue gas inside the tube, and surrounding it is the uh, boiler water meant for evaporation into steam. And while water tube boilers, the water flows through the side of the tubes and it is being surrounded by the and is being surrounded by the flue gases. So the name signifies two things. The fire tube means the flue gases goes through the tube, and water tube means flue gases water goes inside the tube itself. There are essential differences due to higher steam capacity and pressure. Fire tube boilers generally needs higher diameter shell because steam pressure is comparatively high and capacity of the fire tubes capacity, and with large diameter shell is being used there. But water tube boilers, the water flows through the tube and flue gas outside prevents হ্যালো, হ্যাঁ আমি একটা ক্লাস নিচ্ছি বুঝলেন, আমি একটু পরে রিং ব্যাক করছি আপনাকে। The water tube boilers, where the waters through the tube and flue gases flow outside them and puts the pressure in the tube, and relatively small diameter drums can be used here, which is capable of withstanding extremely high pressure if the medium steam generator or the medium steam generator itself. If the diameter of the drum becomes very high and it processes high pressure steam, its thickness is supposed to be the higher than low pressure steam itself, because in that case that we have to make costly drum with higher sheet thickness itself. Now, water tube, what is we have? There are two different varieties of straight tube boilers. Varieties of water tube. What is straight tube? Another is bent tube boilers. The water tubes have several stages. Water tube boilers went through several stages. Say, earlier design employed straight tube with headers at each end, and because straight tubes can be installed can be installed quickly and can replace rapidly. So there is no bend, and they are connected to the header in both the sides. Header means there is a chamber where the steam or water is being assembled and then supplied goes through the steam itself. Here is a water tube. Here through the header, the water meant for boiling steam goes inside. Generally, the tubes are here made up 75 millimeter to OD and inclined upwards at about 15 degrees to the horizontal itself, and staggered means it has specific diameter of around 75 millimeter. Are 75 to 100 millimeter means 10 centimeter OD, and generally inclined. It is although inclined at about 15 degrees to the horizontal itself and staggered. It is not parallel, but they are fixed in a staggered mode. Nearly saturated water leaving the drum flows through the header itself. Means all the tubes called the headers flows through the headers called the down command into the tube. What happens so? From the really saturated water means it is already heated and near it is saturated, near it is this water is saturated with steam, and it leaving but not totally converted into steam. It comes from the drum, flows through one header, then called that it is called downcomer. Means header means it's the collector of this water, and this collector is same for all the tubes. Tubes are connected between the collectors, and through the collectors, this tube goes to the downcomer itself, and through this one heater, which is different as the downcomer. Means the water and steam vapor mixed this comes down through the downcomer into the tube itself, and then it goes through the tube, and while flowing upwards in the tube, because the tube has some certain slopes around 15 degrees with the horizontal, it is by the pressure of the incoming water tube mixture, the water flows through the tubes, and some water is being heated by the flue gases flowing inside outside the gases itself, and thus it is transferred into vapor into two-phase water steam mixture, went back to the drum itself through the other header called the riser itself. The density, nearly saturated water density, nearly saturated downcomer was larger than the density two-phase mixture in the riser, because when the water is saturated with steam, now it is again goes through the tubes where it is being heated and heated, and motion of the water is again heated to the steam, converted into steam, and so the density of this mixture in either downcomer and or the riser is not exactly same, but it is a bit different. Here, saturated water in downcomer is much more than the saturated water in the header, because it is already heated by the flue gases inside the tube, and almost all of them are converted to the vapor itself. This density difference is called natural calculation, because as the incoming water has higher density, it has higher weight and push the outgoing water through the tube into the riser itself. The drum was generally either parallel to the tubes, original longitudinal, or perpendicular to them across drum. The feed water for the feed water heater flows through an economizer in the drum. Feed water heater then flows to the economizer drum, and with then supplied saturated to superheater itself. Superheater lower end of the downcomer was connected to a mat drum, which is collected sediments from the steam itself. Here it is a rough sketch of the steam generator. Here what we see, water tube boilers itself, what we see, this is the tubes, and which is inclined more or less around 15 degrees to the horizontal itself. Here is the downcomer, and this is the full drum from mixture of steam and water. It is through the downcomer, the water comes down here and goes to the straight tube, which is these tubes are straight, and they are one end is connected in this downcomer, and another is connected in the riser, and from the downcomer, a mixture of water and steam comes down by its own weight and own weight, and because it is of higher density, then it goes up through the tube by means of its own weight, and where it is being heated by its surrounding flue gases, and then this water it remains saturated, but this vapor portion of it is remain increased and water portion remains less. That's why its density is comparatively less. Then through the riser, it goes back to the drum itself. And here is the stoker itself, and the flue gases are generated and comes sent to the surrounding the tube itself. Now it is a straight tube boiler, because tubes are straight from the straight. There is no bend from one end to another, and it is being fixed between the riser as well as in the downcomer itself. But this process of heat generation is more economical, because straight tube can be easily replaced, and it will be opened up and clean, and again then fix it for the next operation itself. Now there is another thing, that is here the fourth superheater is itself is the drum. It is the drum is the cross side. Here is also straight tube boilers, and drum is in the cross side and following more or less same thing, down command riser, and there is a superheater shown here. From the right itself, it goes to the superheater. The steam goes to the superheater and get the required heat, and then supplied to the turbine itself. First drum, take. Now, what happens here? The circulating water and discharge, water discharge through the blowdown, a single horizontal drum about 1.2 meter in diameter can accommodate only a limited number of tubes and hence a limited heating surface. Depending on the capacity itself, more than one drum can be installed and in parallel, which goes from one to another. Then water vapor and water mixtures goes from one drum to another. Those are located in parallel itself. Side by both are supplying, being supplied, and both the both are being supplied the water and water and vapor mixture, and both supplies the vapor and certain amount of water outside itself. The longitudinal drums are limited to low pressure, generally up to only 23 bars, but steam capacity is around 10 kg per second. But cross jump boilers have accommodated much more tubes, the longitudinal drum boilers, because of the geometry and bolt with a heating capacity of almost heating surface of 93 to 2200 cubic meter, square meter. Pressure is around 100 bar and steam capacity is around 0.63 kg. So if we place the longitudinal drum along the tube will have very little capacity, very little space left for accommodating both of them. So drum is supposed to be of lesser diameter, and their capacity, their low pressure absorbing capacity is low, and steam supplying capacity is also low, that is only on 10 kg maximum, and heating surface is overall around maximum 930 meter cubic square meter. But cross drums don't have this accommodation problem, so they can accommodate on many more amount of tubes, thus in the longitudinal drum because of the geometry, and so the heating surface becomes as high as 2200 square meter, pressure capacity 12 to 100 bar, and steam capacity is 63 kg per second itself. But next we comes the bent tube boilers. Straight tube boilers has the following disadvantages itself. They has less accessibility and power. Based on the power inspection capability. Considerable time, labor, and expense are required to open up and close the bolts of the heater and remove and replace the gasket and handle caps, all these things for the tube inspection, replacement, and inadequate design and imperfect fabrication of handhold caps results in many leakage, and which was a continuous source of annoyance to the boiler itself. But the circulation was sluggish due to low head and limited steam disengaging surface made inadequate separation of steam and water, reducing the steaming capacity itself. Then bent tube boiler itself. The tubes were so bent that they entered and left the drum radially. Thus, as an example of a bent tube boiler, the drum a 4-drum Stirling boiler is shown in the figure. It is not in the next page. There easy access to every tube. Just I'm showing you the picture. If everybody is there, This is a 4-drum bent tube boilers. These drums are 1, 2, 3. This is 1 drum, 2, 3, and 4. The tubes are being supplied through the hot gases are supplied to these tubes, and the bent tube tubes are so bent that they can enter and left the drum radially. So it is bent around the radius of the drum itself. There is not required any riser or another members like riser or economizer, etc. Riser and down comer. They are directly coming inside the drum itself, all of them, and coming out of the drum by means of bent surface. So you have easy access for the tube, and the combustion gas flows upward from the furnace to the first blank of the tubes connected to the front drum. Here it is flowing up to the first blank of the tube to the front drum. Next, then and mud drum, and then through the superheater, then by the second and third tube banks connecting to second and rear drum. Now, so here what we see here is the burners are here. Here we are having the hot gas burned and water walls on the furnace wall. For what these are the water walls, because the water is being heated from the furnace from here. So this is it is the straight here, and from here the steam water mixture goes inside the drum in the radially, and these slags are coming down to the mud drum. From radial it starts going to the second drum, from second to third drum, and from the second drum it is superheated steam is sent to the superheater, and then goes out. After superheating, it goes out goes out to the turbine itself. The superheater is also being heated by this hot gas itself, and the portion which is not sent to superheater goes to the third drum, and its muds are coming down in the mud drum itself. Here the gases are surrounding all the drum seal and coming out from the gases to the air heater itself, where the air is being heated and sent to the mixture itself. There are the baffle walls inside the banks of the tubes of the drum, and you see baffle walls are required to prevent the movement of the prevent and control the movement of the hot gases around the drum, and they should come through here and through here and go out through here and through here. That's the way it is going out and coming in and going out. Its banks are connected to second and rear drums. The gases then flows out to the economizer itself in counterflow arrangement. The feed water from the economizer first, because being after heated, where economizer is heating the feed water by the leftover heat of the flue gases itself. Then it comes the rear drum through the banks of the tubes, and then up on both the center and front drums of the tubes, right through riser to the center and front drum. All three drums had their steam and water gases interconnected at top and bottom. The tubes were typically 75 to 70 millimeter and spaced 120 to 125 millimeter on centers. The easy replacement of defective tubes without removing the neighboring drums itself. Only one defective drum is can be used. We don't have to open the headers, etc. So it is very easy to maintain itself. Next comes the heat absorption and waterproof water tube boilers. Now, in the water-proof boilers, feed waters are heated in three kinds of heat exchangers. First, the economizer, evaporator, or down riser circuit, and the superheaters. Then what happens here? The feed water from the high-speed heaters enters the economizer itself, where it is being heated by the first. Comes to the economizer. Then is the feed water from the low pressure, high pressure heaters. It is heated to a certain extent, then goes to the economizer, where the feed water is being heated by the outgoing flue gases till it is saturated liquid at the pressure, and then it goes to the drum, fed to the drum, and saturated water falls through the down command into the bottom header and moves up through the riser, where the water is partially again boiled back to the steam back and then back to the steam drum. Saturated steam from the drum goes to the supervisor for being heated to the desired temperature. So the step is like this. First economizer, the heat from the is heating the feed water, which is getting it is receiving the feed water from high speed heaters, but if the feed water is not boiling, in not economizer, it is also not boiling because it is used the flue gases meant for running the tubes, meant for heating the water inside the tubes of the boiler. Next goes to the high speed heater, as I said, where it for flue gases and is saturated in the pressure, then it is fed into the boiler drum itself. So the what we boiler drum got by from the water is first heated in the heater, then to the economizer is converted partly to partly to density your moisture and partly to heater itself, partly to the water itself. Next it goes to the feeder by evaporator of the boiler drum itself. The saturated steam from the boiler drum goes to the superheater after being heated to the desired temperature itself. If the pressure drops during the entire period, if the pressure now the saturated water falls through the downcomer into the bottom heater and moves out to the riser where the water is partially boiled back into the drum. The saturated stream from the drum goes to the supervisor for being heated to the desired temperature itself. If the pressure drops during the entire heating process and any external heat loss are neglected, if the pressure drops during the entire heating process and any external heat loss are neglected, the line 1-4 represents the heating process in TS diagram. So what is this here? Pressure drops during the entire heating process and any external heat loss are neglected. That is 1 to 4 represent the heating process in the TS diagram. For each kg of stream formed, the heat absorbed in the economizer in the required liquid state in the evaporator liquid to vapor transmission phase or latent heat of vaporizer and in the superheater are given by this equation. Q economizer is H2 minus H1, Q evaporator H3 minus Q evaporator is H3 minus H3 minus H2 itself, and Q superheater is H4 minus H3 itself. The percentage of total heat absorbed in the economizer, evaporator, and supervisor are like this. Economizer, Q evaporator, top in the numerator, Q economizer multiplied by 100 or H2 minus H1 divided by H4 minus H1 into 100. Now, let us go through the sketch itself. Let us go through the heat absorption in a water tube boiler itself. First, we have this is the water boiler drum, and this is the downcomer of the drum itself. And this is the evaporator, the full drum from here to here. It's actually the boiler drum called the evaporator, otherwise named as evaporator itself. Or this is the furnace. Full portion is defined as the furnace itself. So here the furnace is having the molten flue gases, like burning flue gases, which is being surrounded with all other heaters, all sort of heater economizer, and thus giving the necessary heat for conversion of water into the steam itself. So this is the drum. From through the drum timer, it is comes back, it is come down, goes through this line and through riser and through evaporator. It again receives heat, relative heat, and it converted into steam and then goes back to the drum itself. So evaporator is heating the boiler here. Another time is the superheater. It is receives the moisture from the top of the drum, goes to the supervisor and heated up to that desired limit, and then goes up the horsepower out to the horsepower turbine. Reheater first high speed turbine, the water release comes to the from the high speed turbine to reheater, and reheated and goes to the low pressure or intermediate turbine itself. And another thing is they are getting the heat from the furnace again. So all these heating downcomers, economizers, evaporator, all are getting from the furnace. And next, FW is the from feed heater. The last thing we have done. This is carrying uh, high speed high pressure heater. Next is sent from the high pressure from it is coming inside the circuit. It is being heated in the furnace itself, goes for high pressure heater, heated to the drum itself. Now from the drum, the vapor is selected from the top and goes to the superheater, and from the superheater it goes to the top on to HP turbine. And the furnace is there, which is supplying heat to superheater, the downcomer, as well as any other phase change of the um, water. The feed water is coming. The high speed heater goes to the here. Here high speed turbine is feed water coming, and then from through reheater again. It is inside the furnace reheated again. Go to the high speed IP drawing itself. So what we got, here we got the cytometric chart in TS background, where we are following the path 1, 2, 3, and 4. From 1 to 2, it is the economizer. 2 to 3 is the evaporator inside the boiler, and from 3 to 4, it is the superheater itself. Now, so what we have here, the Q economizer is given as H2 minus H1, and Q evaporator is given as H3 minus H4, and Q H3 minus H2, and Q superheater is equal to H4 minus H3. The percentage of total air absorbed in the economizer, the evaporator, and the superheater are the or and the percentage is Q economizer divided by Q economizer plus Q evaporator plus Q superheater into 100. So the Q goes to the economizer itself, H2 minus H1, and all these three terms is equal to the H4 minus H1 is into 100. The capacity of the evaporator itself, Q evaporator divided by the whole heat supplying capacity, same is Q superheater divided by supervisor is QCH, and Q economic plus Q evaporator into QSH into 100. If the reheater is used, the fraction of the total heat assembled in the reheater can be simultaneously estimated. The use of a large number of feed water heater, up to 7 or 8, means a smaller economizer, and a higher pressure means a small boiler surface, because the latent heat of evaporation rapidly decreases with pressure. Thus, a modern high-speed, high-pressure steam generator sequences where superheating and reheating surface and less boiler surface than older ones. So modern means steam generator requires more superheating. So nowadays we are going for no superheating and reheating, and that too with the help of same flue gases without spending anything more than this flue gas itself, and less boiler surface than older units. The fraction of total heat absorbed in superheaters along may be as high as 60% in a modern boiler. Now the circulation. চোদ্দ Now, the flow of water and steam within the boiler circuit called circulation. How we are supposed to flow the water and steam continuously throughout every connecting parts of the boiler. This is an important thing defined as circulation itself. This adequate must be adequate. It must be adequate. It must be adequate to carry out the heat from the furnace itself, which is supplying the heat from through flue water. If the circulation is caused due to density difference, the boiler is said to have a natural circulation, generally caused by a pump. It is being forced or controlled circulation. So we have to use the pump, not that due to only density difference, which we have discussed earlier, but a pump is required to maintain the proper flow all the time itself. Now, a simple demonstrator a simple downcomer riser circuit is connecting a drum and a boiler as shown. Sometimes what happens, just 1 second. A simple downward come riser circuit is connected and a header is shown here. This is our boiler reservoir or boiler drum. This is the header itself. This is the downcomer through which the liquid water and vapor mixture are mostly saturated coming and being collected to the header. From the header, it is again sent to the riser tube and heat to the boiler itself. Here, due to this incomer, some of the moisture will be reduced, and then it is sent again, and then the moisture content along with the previous moisture is just going out. And using this process again and again, you can create by the same volume of water, we can create enormous amount of steam itself. The density of the steam under the mixture in the riser is less than that of the standard water in the downcomer, and as a result of this density difference, a circulation current is set. You see, in the downcomer, density is more because there are more amount of gas, more amount of oxygen. I mean, the water vapor as well as liquid water is present. So its capacity and this difference is a calculation of the count efficiency. The feed butter from the economizer enters the drum and saturated steam is taken out from the drum to the superheater itself. Drum in the downcomer, as a result of the density difference, circulation starts without the pumping other than the pump part, then set within the drum riser circuit, downcomer riser circuit. Feed water from the downcomer enters the drum, saturated steam is taken out of the drum in the supervisor itself. The pressure head available for the natural circulation is given by delta P G into H by multiplied by PD into ρ D into PM. Means Density is the density of the saturated water in the drum plus minus density of the stream. It says the drum is plus, I mean minus. And Pm is the mean density of the steam water vapor in the riser itself. For simplicity, mean density Pm is mean density Pm may be taken as arithmetic mean of the density at the bottom or top of the riser itself. So density at the we got the riser, the density at the bottom of the riser we have plotted, and density at the top of the riser riser is also taken WIP divided by 2. The per program, the P bottom, the rho bottom, rho D, and rho WIP is V by WIP by V. VWIP is the VT into XWP VPG, where depth WP is the quality of the fixture mixture at the top of the round set, and good surface finish as the good dryness fraction itself. Now the rho bottom is equal to rho D. Density at the bottom is equal to density of the diameter, and rho WP is equal to 1 by V omega P. V omega is equal to UT plus XWP PAG. XP is the quantity of mixture, quantity of stream, quality of the same mixture, and at the top of the riser, and is often referred to as the top dryness fraction itself. The maximum height of the furnace is fixed by rate of burning of the fuel and the fuel release rate. For a custom, H delta rho is proportional to rho D minus rho M. Higher the density difference, more will be the pressure rate available for the internal circulation, natural circulation itself. Okay, so much for the day. Nobody of you arrived. I am stopping the class here.